Hi guys, it's me, Michelle Geomatics, and today I'd like to talk to you about hotspot analysis. What you see on my map is tornado data for the year 2013. The data came to me as lines showing the path of a tornado, and I converted those lines to points and then used the points to do my hotspot analysis. So hotspot analysis is a way of finding the hot and cold spots in your data. The input data needs to be points or polygons, and the tool that you use to perform the hotspot analysis is in the Spatial Statistics toolset, which is available at all license levels, so you do not need a special extension for this. And then in the Mapping Clusters toolset, you'll see a hotspot analysis, and the one I use is the optimized hotspot analysis. I use the optimized because it presets some parameters based on your data. So if you're familiar with the statistical processes and you'd like to have total control, you can use the regular hotspot tool, but I recommend the optimized. So I ran the optimized hotspot analysis. You can see it just asked for input features, which were my point data for the tornadoes. I specified the output features. I did not use an analysis field. An analysis field would be some measurement that happens at those points. So in this case I have tornadoes, and I'm interested in the hotspots of where the tornadoes are occurring. So I don't need an analysis field. I could do a second optimized hotspot and use an analysis field because my tornado data include an attribute field for the Fujita scale rating, a 1 through 5 value for the intensity of a tornado. And then what that would show me is the hotspot of the most intense and the least intense tornadoes. But my first round I did not fill in an analysis field. And then there's an aggregation method. I used two different methods here. I used the default method, which is the one that you see here, which is using fishnet polygons, where the software generates polygons behind the scenes and then aggregates the points based on those polygons. The second one is to snap points together to create aggregated data. So let me show you the results that I came up with. For the first one, when I used the default fishnet method, I'm just going to turn off my tornado point so you can see, the result were these polygons. And I don't get a continuous surface. I just get kind of polygons that sort of show me, okay, there's a hot spot here, but it doesn't show me the full picture. The second time I ran the tool, I used the snapping aggregation method, and the output are points. So I have points that tell a similar story, but I have to read between the points in this case. Here's a trick. When you get the point output, you can come into Spatial Analyst. If you have the Spatial Analyst extension, there are several interpolation tools, and I'm just going to run an IDW. Now let me move this aside and show you when I expand the results for the layer that gets added automatically from the hotspot analysis, it comes already symbolized. So the data include this new attribute field called GI-bin, which shows the statistical significance, the confidence interval of the data. And you can see that it ranges from red for a hot spot down to blue for a cold spot, and then yellow points are not significant. So the results are statistically significant. I want to use the results from that attribute field to work with my IDW interpolation. So I'm just going to choose that layer, and then for the value field I'm going to choose that GI-bin field that we see symbolized from the hotspot analysis. And I'm just going to accept all of these defaults and go ahead and run this tool. And then we can see the results. So we see our hotspot here as a raster image. Let's turn off these points. And I can see where the hot spots are and the cold spots. And then, of course, it's raster data, so I get this blocky look, which you could work with. I could set the transparency on this layer so that it kind of blends in a little bit nicer with the background and make this look better. So let's just turn on some transparency. We'll make it 40% transparent, and I can work with the results that way. So if I wanted to run another hotspot analysis using the Fujita scale, I could come back down to the hotspot analysis tool, which is in spatial statistics, mapping clusters, optimized hotspot analysis, and my input features will be the tornado points. This time I'm going to specify my analysis field as the Fujita scale, and that's really the only choice I have to make, so I don't have to worry about specifying an aggregation method if I've chosen an analysis field. So I'll just run this analysis, and I end up with points that this time are showing the hotspots of the most intense tornadoes. So hotspot analysis is a really nice tool to use because it's easy and the results that you get are statistically significant. So you're really revealing patterns that you may or may not have been able to detect with your naked eye. So play around with the tool, see if you like it, and let me know what you think. This is Michelle Geomatics saying goodbye for now.